This lesson is on similarity, and you are mostly dealing with triangles, but it could be other shapes as well. Similar shapes, small compared to large. You want to see a neat scale factor little display thing. Go to this website and see if I can make this screen come up here. Yeah, at NASA for scale factor of the universe. And it shows just how big and how small we really are. So check it out in your free time. All right, what makes something similar? They have the same exact angles. All the angles match. Okay? Sides are in the same proportion. Now that does not mean that they are equal. So like if I've got a rectangle and another rectangle, well, if the short end here is 4 and the short end here is 2, that's twice as big. The same proportion means if this is 3, then this would have to be twice as big, 6. That's the same proportion. This one's doubling and this one's doubling. So they have to be at that same rate of increase. All right? They can be rotated, reflected. It doesn't matter how they're turned or flipped over. Okay, and then we start talking about scale factor. And scale factor is nothing but the number that represents how much it's changed. Like I said, it was doubled. That means it's a scale factor of 2. 2 times bigger from the 3 going to the 6. That's a scale factor of 2. All right, if it got half the size, it would be a scale factor of 0.5. Half, all right. So if it's a scale factor of 1, it's not going to change, and that would mean they were also congruent and not just similar. Congruent means they're a perfect twin, but similar means there's a small one and a large one. All right, so we're looking for same angles, and this plays into something we'll look at a little later. Angle, angle, angle postulate, where you've got 3 angles. Now, do I have 3 right now matching? I got 30 matching 30, but I don't have another 40. Can I find a missing angle? Let's see, yeah, 40 and 30. This triangle has to make 180. I've already got 40 and 30. Minus 40 minus 30 leaves me 110. This big one right here, 110. Well, that's a 110. And then the vertical would match 110. So I really only need to check 2 of them in a triangle, because if I've got to, think about it. If I need 180 and I subtract 30 and 110, I'm going to end up with the 40 again, because the 1, 2, 3 pieces that make up that 180 are the same 1, 2, 3 pieces we already had. And we had 2 out of the 3, and there's only 1 other one that would fit in there. So yeah, those are matching. All right. And then here, 60, remember 30, 60, 90. So that would be 30, that would be 60. So if you got 2 parts matching, you're good to go. But 3 is, all. All right, so let's check the proportions here. The small compared to large. And what I suggest that you always do when you're working these problems is put an S in the small one, L with a large, and when you're setting up the proportion, you're setting up the ratio, I always put the small over the large. Now you don't have to, but you do have to be consistent. So if you pick small over large, that means all the smalls need to be on top, and then all the larges need to be on bottom. And be careful, not to mix them up. If you mix them up, the whole problem is going to be messed up. If you started with large over small, that's okay, as long as all the larges stay up top and all the small stay on bottom. So, but I usually do small over large. So setting these up, are these going to be similar? Let's check all the ratios. The smallest piece on this one, this is the small, what's the smallest thing? The 4. Goes with the smallest piece over here, 8. All right, then we're going to keep going. I think I've got these printed up. Because size. Yeah, 4 and 8, 5 and 10, and 6 and 12. Now, that looks fine, and you can do those in your head, of course, But this scale factor, that's what K stands for. We use it now, but you'll see it in later formulas and other math. The scale factor, is it all the same? You got to reduce them or divide them and see if they all come out to be the same thing. And they do. So we say, yes, they are similar, and the symbol for similar is just a wavy bar by itself. No equals underneath like congruent. Why did they match? We had 3 sets of sides. We didn't have any angles on that, so that would be side, side, side postulate. We'll talk about that more in the next chapter. Or in this chapter. It's in both. So keeping on, let's see if these are similar. The small, how do I know which one is the small if they look this close? Well, look at the numbers. This has smaller numbers on it, doesn't it? Alright, so that's your small, and you've got a large here. So if we were going to set them up, small over large, pick out something from the small, let's start with 4. The smallest piece on here is 4. What's the smallest piece on this one? The 6. So 4 goes with 6. What's the medium over here? The 6. What's the medium over here? The 8. And then finally the biggest here is 8, and the biggest on the other one is 10. Now you gotta reduce them to see what's going on. See if they're gonna be similar. This one reduces 2, you got the calculator. If you got basic calculators, usually there's a button to make it reduce the fraction. If not, just make it decimal. 2/3. Reduce here, 3/4, and then here 4/5. None of these match, so guess what? Are they similar? No. Those fractions have to come out to be the same. Exactly the same. Alright, so we're going to determine, are these similar or not? With the rectangles, 8 over 12, that's the short piece with the short piece, and then 10 over 15, reduce them both. This makes 2/3, this makes 2/3. Yes, these are similar. Okay, that's all you're having to check. And you got to check all of them, yes. So if I've got here, this is isosceles, so I have a 3.5 and a 3.5, and a 7 and a 7, at least check that. If this one was scalene and that was isosceles, that'd be a dead giveaway that it was not. But these are both isosceles. So the 3.5 is going to go with the 7, because it's the leg and the legs, and the base is 3 over 6. Now that seems a little weird with the decimal, but if you reduce that, or just divide it, 3.5 divided by 7, you get 0.5. 3 divided by 6, 0.5. They are similar. 3.5, $3.50 is half of 7, right? Know your money. If you don't know, somebody else is going to be taking it. Okay. All right, moving on. So, yeah, we'll check those other two. And I think this is a no, and this is a yes. It does work out. Now, this one you'd have to say the short side, 13, goes with the whole big triangle right there of 26. So we'll talk about those in another one. So our main thing is to figure out what missing sides are for similar shapes. So if they're similar, what you want to do is, make sure you know this is the small, this is the large, so that you can be consistent. When you're setting up that ratio, small to large, you're going to pick out one from the small and one for the large. I want to find side A right here. So set up the small compared to the large. Now, you're going to have to think about what parts go together. Now, on this one, it's pretty simple. They're turned the right way. They're turned the same way, and it's easy to spot. 9 from the small matches up with 12 from the large. Then 6 from the small goes with A from the large. So you get it set up. And then you're going to, what are you doing? Equal, 2 fractions equal, cross multiply. So you get 72 equals 9a, and finish the math off, and a is 8. So 8 would be our answer there. Now, they don't get as easy when I start flipping them around and turning them different ways. Now, you might think you can guess, but let's still do what I told you to do. Put the small and the large in each one, so you keep them straight. Set up one ratio, small to large. All right, pick out something from the small, like 6. It doesn't really matter. Now, you can do a couple different ways to determine what goes with the 6. You can say this double hatch mark is opposite to it, but most people, I think, prefer to say something like 6 is between what two corners? 6 is between this corner with one hatch mark and the corner with no hatch mark. So a single and no hatch mark. Here's a single on the large, and here's the no hatch mark. So X goes with 6. X is in the large, and 6 is in the small. Make sure you're keeping it straight. All right, so now we want to pick something else. Now here's where it's easier. We don't want to pick Y and X in the same setup. You can't do an X and a Y. So we got to do 8. So we're going to put 8 over. Now what's 8 between? The double corner and the corner with nothing. So the double corner and the corner with nothing. So that'll be 10. So 6 times 10 is 60. 8 times x is 8x. Divide that out, and I think that's 7.5. Let me check my note here. Yep, 7.5. All right, so then we still got to find the y. So what we need to do is start over with a new ratio. You're still doing small over large. You want y from the small to go with what's left, 24 from the large. But this time, you don't have anything else. We've already used all 3, but you can use the 8 over the 10 again. We had both parts of it. Use it again. 8 over 10, and now cross multiply. So 10y equals 192, and divide that out, and you get 19.2 for the y side. And that's pretty much it. So it can go with other shapes. So you still do the small compared to large, 8 over 12. This time it's got a little algebra, 10 over y plus 1. Now to cross multiply, a little bit more of a challenge, not much. This is a group. When you got adding or subtracting in a fraction, that makes it into a group right there, that adding or subtraction part. So you can't bust it up. You can't just say 8 times y. It's 8 times the group, and just leave it grouped, and then 12 times 10, 120. Now what do? You distribute. Boom, boom. So 8y plus 8 equals 120, and then you can finish it out and do the rest of the math. So don't worry about that too much. All right, this is at the bottom of the worksheet that you're going to have to do in class, and so it's just asking you a little bit about some and finding the same kind of stuff. Here, obviously, we got the small and the large. You're having to look a little closer at some proof stuff that'll be coming up. DFG is stated to be similar to HKM. That means when they write it out in those terms, and we didn't talk about this earlier, we should have, D, and this is at the bottom of your notes, D does match up with H. When they write it out like this, those parts go together. F goes with K, and G goes with M. So D with H, G with M, F with K. So they're turned the same way. So that's going to help us knowing that feature. All right, and then they're wanting the scale factor, but which one did they say first? HKM, that's the small one, compared to DFG. So what's the scale factor? Well, we don't have all the sides, but they already said they're similar. So any of the sides we put together will be the same scale factor. So 5 compared to 30, and of course we need to reduce it to know the scale factor. And that would be 1 over 6. So that's the small compared to large is the scale factor. What would angle K measure? Well, we don't have F, to compare it with. All the angles are supposed to be equal. So if I had F, I would know what K was. Well, that's just a simple 180 for your triangle. That gives you 50 for F, 180 minus the other 2, and so K is also going to be 50. And then here's where they try to be sneaky about it. GD as a ratio compared to MH. Now let's look. We don't have a number for GD and we don't have a number for MH, but it's a ratio. All right, which one is? GD is the large, isn't it? And MH is the small. So they just flipped it. Guess what? We already have it. That 1 over 6 is just 6 over 1. They flipped it over to try to trick you and see, hey, you don't have any numbers, but yeah, you do know the ratio, and that's all they're asking for. So how long is MK? We're just looking for an X piece there. That'd be a small over large. X goes with 42 equal to 5 over 30. Cross multiply, and you have it. I think it works out to 7. Okay. All right. There you go. Classic ACT question. At a certain time of day, okay, the sun comes out and shines down on this tree and a big old post sticking up. They both have a shadow that is, where do you see your shadow? On the ground, right? Shadows on the ground, all right? And so let's fill that in. At a certain time of day, the 6-foot post, that's up and down, cast a 3.2 foot shadow, and the tree cast a 10.8 foot shadow. Can we figure out the height of the tree? Don't you see two similar triangles? They're similar because the sun is so many millions of miles away that that angle right up here that it's making with the sun and the shadow right there, and then this tree and the post hopefully are at right angles standing straight up, then you've got two matching angles, and that's enough. So we do have similar, so 3.2 from the small goes with 10.8 from the large, over, go back to the small, 6 foot for the small, over X from the large. Cross multiply and work it out. That tree is 20.25 feet tall. Very cool? Awesome.